In a random sample of 21 people, the mean commute work time to work was 32.7 minutes, and the standard deviation was 7.1 minutes. Assume the population is normally distributed and use a t-distribution to construct a 90% confidence interval for the population mean mu. What is the margin of error of mu? Interpret the results. When we look at this particular problem, what we want to do is, when we're creating a confidence interval, is we are going to actually generate the margin of error at the same time that we generate the confidence interval. And we're going to use the following formula for error. Error, or E, is going to be equal to t sub c, which is our critical t value, times the standard deviation divided by the square root of the number of data values, or the number of people in the sample, n. The confidence interval, on the other hand, is going to use that error, and it'll look like this. We're going to take the population mean mu, and on either side of that, we're going to either add the margin of error to our x bar, our sample mean, or we're going to subtract it. So if x bar is the sample mean, then the confidence interval will look like this. It'll be x bar minus our margin of error, E, and it will also be x bar plus the margin of error, E. Now remember that for this problem we have a random sample of 21 people, which means that n will be equal to 21. The mean commute time, which is what is given as our sample mean, is 32.7, and then the standard deviation was 7.1 minutes. Then we're told that we will assume the population is normally distributed, but we're going to use a t-distribution to construct a 90% confidence interval. The reason we're using a t-distribution is because our sample size is less than 30. So that means that we need to find t sub c from our table. And this will be table 5 in the textbook. Now, in order to find t sub c, we need to know what our degrees of freedom are. The degrees of freedom, d dot f dot, will be equal to n minus 1. So since n is equal to 21, the degrees of freedom will be equal to 20. And then we need the t-distribution table, which is this right here. We're going to look for degrees of freedom. Degrees of freedom, this is this column. So we come down and we look for degrees of freedom that are 20, which is this right here. And remember, we are looking for a level of confidence C, and it is a 90%. So now where do these two meet? And our t sub c will be 1.725. And we'll go ahead and write that right here, 1.725. So let's go ahead and calculate E. That is going to be equal to t sub c of 1.725. And we are going to multiply that by the standard deviation, which is 7.1 s, over the square root of n, which in this case is 21. And this will simply be typed into any good scientific calculator and you'll type in 1.725 times 7.1 divided by the square root of 21. You can use parentheses on this if you want to. You can type it exactly the way it's written. And your answer will be 2.6726. And it is a continuing decimal. We're going to generally round to 1 or 2 decimal places, so I'm going to go ahead and round to 2 decimal places for this, 2.67. And now we'll create the confidence interval. Remember what I said, the sample mean minus this value. So if the sample mean is 32.7, and we subtract from that 2.67, and that will be less than or equal to the population mean mu, whatever that may be, and I'm not sure what it is, and that will be less than or equal to the sample mean of 32.7 plus the margin of error, which is 2.67. And then we simply do the arithmetic. This will be 30.03 less than or equal to the mean, the population mean I should say, less than or equal to 35.37. Now, I want you to be aware that this right here is what we consider the lower limit. And this over here will be the upper limit. The confidence interval can also be expressed in terms of interval notation. So we'll do a bracket and 30.03, comma, my upper limit of 35.37. Now you have to pay attention to the directions so that you input this correctly, because it may or may not want you to round to 1 or 2 decimal places. In this case, the directions call for 1 decimal place, so the confidence interval would be 30.0, comma, 35.4. Now that's the first part of the problem right here, number 1. The second part is, what is the margin of error of mu? Now we did come up with a margin of error, and we're just simply going to state that the margin of error for mu is what we calculated for E. And we need to make sure that we're paying attention to the directions, and in this case it also wants you to round to a single decimal place. And since the E that we calculated right up here is 2.67, we will round that to 2.7. And then the third part of the question is interpret the results. So let's do that. Interpret the results. Well, what do the results mean? Well, we need to understand what exactly that we're looking at. Remember that n was equal to 21. We had the population mean, x bar, and that is equal to 32.7. We also know that the standard deviation is equal to 7.1. And keep in mind that both of these are in minutes. And then we calculated error, and the error is equal to 2.7 when we rounded that. And then we ended up with a confidence interval, and that's a 90% confidence interval, and that went from 30 minutes up to 35.4 minutes. So what can we glean from this? Well, basically we can state that with 90% confidence can be said that the population mean commute time is between the bounds of the confidence interval. Now, what does that mean? It means that when we consider the sample mean of 32.7. This is the sample mean. And we analyze this from the confidence interval that we have generated right here from 30 to 35.4, that the population mean, that means all commuters, the mean will fall between 30 minutes and 35.4 minutes.